All right, so today, guys, we're going to be talking about the key characteristics of exponential functions. So some of this stuff, like I said, is going to be very repetitive. It's going to be some things that we've actually talked about in previous lessons. But the key focus today is on exponential functions rather than linear. So what we're first going to talk about is domain. So if you haven't already, go ahead and take your notes and find the slide that says domain. Okay, that's what we're focusing on here. So with domain, go ahead and write this underneath domain. But in your box, you're going to write down the words represents the x values. Okay, that's what we want to write down as our definition. Represents the x values. And what I mean by that is the domain is going to be represented by just the x values. If you recall, in the linear unit, we talked about domain reflecting on the x-axis, or the x values. So anytime we have the domain, we're dealing with the x values. And that's the key here, x values. So make sure you write that down underneath domain. Now, to work a problem out with this, what we're looking for is we're looking at the x values. So with all of our graphs, you're going to need to go in and add this. But if you haven't already, go ahead and put arrows on the ends of all your lines so that you have that information to refer back to in the next problem. Now, what we're going to focus on here is the domain. So domain is going to be all the values that go to the left and all the values that go to the right. So keep in mind, this is going to be left to right. So if I look at this problem and I pay attention to this arrow here, where is that saying it's going to the left? Negative what? Negative infinity. So that's approaching negative infinity. Now, as we go to the right, it's going to go up. But not only is it going to go up, it's also going to go up into the right. So eventually, going to the right, it's going to approach what number? Infinity. Okay. So here we can say that we can write it in two different ways. We can write it as interval notation or inequality. So where it says inequality, we're going to write it in inequality form, and where it says interval, we're going to write it in interval form, which interval form is what we're going to be most accustomed to. So for inequality, I want you to go ahead and write down x is less, and then you put two less than signs. And that's always how we start an inequality problem. So here, the lowest value we approach is going to be negative infinity. The highest problem we approach is positive infinity. So for the interval, we know to write the interval as negative infinity to positive infinity, and we can put parentheses around it to indicate the interval. Remember that brackets go around a sign that is going to have something equal to it. And these we know that infinities are not equal to. If you have any questions, go ahead and pause the video and we'll talk about it one-on-one. All right, so next we're going to talk about range. So for range, I want you to, in the left-hand box, I want you to write down this definition. So this is going to be represents the y values. And the key here is the y values. So with range, we're dealing with the y values. Now, keep in mind that range is going to be the values that go up and down. All right, up and down here. So we're looking for the up and down values, or the ones that go up and then the ones that go down, the highest and lowest, in other words. So if we look at this problem, this is a little bit different in the regards of an exponential function. So when you look at this, first off, let's start with how low it goes. So if you look, this problem, you can see that it kind of flattens out at what number? 0. So we know if it flattens out at 0, will it ever go past 0? No, it's hitting what we call the asymptote. So we know that the lowest it can go in this case is to 0, but then the highest it can go to is what? Infinity, because it's going to continue to rise up. So that's going to be going to infinity. And then since it never actually is equal to any of those values, we put parentheses around it to indicate that it gets close to, but is never actually equal to those values. For an inequality, we write it the same way. That's going to be y, two less than signs, and then we're going to have the lowest number being 0, the highest number being infinity. And that just reads that y is greater than 0, but y is less than infinity. So that means it's all the values between 0 and infinity. So with this, the key here is that 0, that's going to change because of the asymptote, which is located right there. If you need a second to write down the notes or have any questions, go ahead and pause the video now. All right, the x-intercept and the y-intercept are what we're covering next. So with the x-intercept, you need to write down where the graph crosses the x-axis. That's going to be the key information to write down under this one. It's where the graph crosses the x-axis. Now understand, sometimes it's not going to cross the x-axis. Like in this particular example here, if you notice, we hit that asymptote that's going all the way across at 0. Okay, so since we hit that asymptote, what that means is that we get really close to 0, but we never actually cross 0. So if we never cross the x-axis, can we have an asymptote, or can we have an x-intercept here? No. So in this case, the x-intercept would be what we would call none. Go ahead and take a second, write down any notes that you need to before moving on. All right, so y-intercept is going to be where the graph crosses the y-axis. So go ahead and write that down underneath your definition, where the graph crosses the y-axis. Now, every problem is going to have a y-intercept. It's not like the x-intercept. The x-intercept is only going to have values where it crosses the x-axis, and sometimes it won't have those values. But you're going to notice that problems will always cross the y-axis somewhere. In this specific problem, it crosses the y-axis at 1. So what we do is, rather than writing y equals 1, we actually write the point down. So here we're going to write the point 0, 1 to indicate that that's where the y-axis is being crossed, or where the y-intercept is. So remember, the y-intercept is going to be where the graph crosses the y-axis. If you have any questions about this or need to write down notes, go ahead and pause the video. All right, next we're going to talk about interval of increase. So the interval of increase, and all you have to write down for this one, it's the long definition, but you just need to know two things. You need to know that it's the domain, which is the x values. It's the domain where the y values are getting larger. Okay, that's all you really need to know. You can leave out that function part. It's the domain where the y values are getting larger. Now, another way you can look at this is growth, or you can look at it as increasing or growth. And we know growth is when a line increases. So it's kind of the same thing here. So with interval of increase, we're looking for growth. So when you look at this equation, is this line increasing from left to right? In other words, is it going up? Yes. It's increasing from left to right. It's growing from left to right. So we know that the values are getting larger. So with these specific problems, what we're going to notice is that they're always going to do one of two things. They're either going to get larger or they're going to get smaller. They won't do both in an exponential equation. So with this specific problem, what we notice is that they're getting larger, they're increasing. So the idea here is that they're always increasing. So we know that based on the domain, that the domain says it's going to be all the way from negative infinity to positive infinity. In other words, it's always increasing. No matter what the x value is, it's always increasing. So with these specific problems, interval of increase is always going to increase. Go ahead and write down these notes and then continue watching the video. So interval of decrease. Interval of decrease is going to be talking about when the line is decreasing, or in other words, decaying. So we got to have a line that's going downward or decaying in this example. So the definition here is the domain is going to be where the y values are getting smaller. So basically the same definition. The only difference is instead of larger, we're getting smaller. So with interval of decrease, our line has to be decreasing. So if you look at this example over here, what do you notice about this line? Is it decreasing?
No.
No. So if the line is not decreasing, then can it ever decrease?
No.
No. So here it's going to be none. Now understand, sometimes the interval of decrease will be something, but it's kind of like with a linear function. It's either got to be increasing or decreasing. It can't be both. So whichever one it's doing, the other one's always going to be none. So if this was decreasing, then the interval of increase would be none. It just depends on which one it's doing. So for this specific problem, we say none because the line is not decaying nor decreasing. Take a second, write down the notes, and then continue with the video when you're finished. All right, next we've got interval of positive and interval of negative. So with interval of positive, we're looking for the interval where the points lie above the x-axis. All you need to write down is this part, above the x-axis. That's all we're worried about here. The interval of positive is going to be above the x-axis. So what I mean by that, and the easiest way for me to identify what's going on here, is by taking I'll take a different colored marker, like a blue marker, and what I'll do is I'll draw a line on the x-axis. So what I'll do is draw a blue line going all the way across this x-axis, just so I can see where my x values are. All right, so once I have a nice blue line going across through there, I can then say, are my values above or below the line? So when I look at this, looking at the top or above the line here, do I have anything above the line? Yes. Then if I look below the line, do I have anything below the line? No. So what this means is that my interval of positive is going to be everything that's above the line. So what I do here is I can say that the positive or interval of positive is going to be everything above the line, meaning it's going to be from negative infinity to positive infinity. The interval of negative is going to be everything that isn't below the line. So here there's nothing below the line, so that would be what? None. So here with interval of negative, okay, negative is a little bit different. And if you notice, interval of negative is this exact same thing. The only difference is it says it's below the x-axis. So with interval of negative, we want to look at below the x-axis. So when you look, there's nothing. Now, understand, if I have a graph, let's say I have a graph that looks like this, and then it's like doing something crazy like this. And let's say that point where it crosses there is at -1. Okay? So if I have something crazy like this, then what I can notice is if I draw my blue line on my x-axis here, it changes a little bit. Okay? You're going to notice something a little different. Because now I have parts of the line that are above, and I have parts of the line that are below. So when I identify the positive and negative for a line like this, the positive is going to be everything that's above. So here I'm going to have everything from negative infinity all the way to 1. Okay? So that's going to be everything from negative infinity to -1. So that would be written as negative infinity to -1. For the negative interval, and you don't have to write this one down, but it's good to see it, the negative interval would be everything that's below. So that's going to be all this that's going down this way. Now, with this particular problem, that would be from -1 all the way to the right, which this is going to keep going to the right towards infinity. So that would be from -1 all the way to positive infinity, that it's going to be below the axis. So you can still have two different types of intervals that are set up to where they're separate from each one. So understand, positive intervals, with these specific types, you can't have them where they're only above or below, but understand that you can also have them where they have an x-intercept, and they're actually going to cross and have both positive and negative. Pause the video if you need to write down any notes. All right, so for maximum and minimum, we don't have a lot changing here. Maximum is going to be the highest point possible, so make sure you know that it's the highest. So with this specific problem, we have the maximum going all the way up to what? What's the highest point? Infinity. So if the highest it can go to is infinity, we say that it can't ever reach infinity, so therefore it's no max. So for the maximum here, we're going to have the highest point possible, and in this case, it's infinity, so there's no max. Now, for the minimum, we're looking for the lowest point possible. So for the minimum, the lowest point possible in this case would be actually approaching the asymptote, and the asymptote we know here is located at 0. So since it gets close to 0 but never crosses 0, that means that for this as well, there would be no minimum. So basically, anytime it has arrows on the end, we can identify that as no max or no min. So a maximum and minimum, pretty simple there. Go ahead and pause it if you need to pause. All right, so real quick on asymptote, asymptote's going to be the point that's never crossed. Now, the easiest way to find the asymptote is to look where the line goes flat. So find where that line gets flat, and then all you're going to do is draw a line straight across to your y-axis, and then you can see that the axis is going to be at 0. So for the asymptote, we're going to have y equals 0. So with this, it's always looking at where it flattens out, and then we can find the asymptote. All right, the last thing we're going to talk about is end behavior. So make sure you know to write down these two phrases whenever you're doing end behavior. So what this says is that as x approaches infinity, or to the right, and then as x approaches negative infinity, which is to the left, because the thing is, negative infinity is always located on the left, positive infinity is located on the right. So as we approach the right, what's happening to the graph? Is it going up or down? Up. So if it's going up, it's going all the way up to infinity. As it goes to the left, or as it comes back this direction, we know it's getting flat and getting close to what number? 0. So we can identify what the values are based on the information in the graph. So with end behavior, it gets a little bit easier because we're actually approaching number values instead of just infinities. If you have any questions about this, feel free to holler at me. You can email me, or you can let me know after class, and we can set up the time to tutor. So if you have any questions, we can get that taken care of. All right, go ahead and work on your work. Thanks, guys.